This question is asking us to write the prime factorization of 120 using exponents. So to do this, we are going to use a factor tree. I'm going to start with 120 at the top, and all that I need to do with a factor tree is try to find two factors that multiply together to make 120. So I know that since it ends in a 0, 10 and 12 multiply together to make 120. The prime part of this is I'm going to try to identify prime numbers as I go. Neither 10 nor 12 are prime numbers, so I'm going to break each one of these down further. 10, I know, is 2 times 5. And here's where I can see that both 2 and 5 are in fact prime numbers, so just to keep an eye on that, I'm going to circle the 2 and I'm going to circle the 5. The 12, as we said earlier, is not prime, so what are two numbers that multiply to make 12? Well, I know that 4 times 3 is equal to 12, and I know that 3 is a prime number, so I'm going to circle that. And now the 4, I know, is 2 times 2, and both the 2's, as we identified earlier, are prime numbers. So what I have here in the end is that 120 is equal to 2 times 2 times 2, those are 1, 2, 3 2's, times 3 times 5. And I want you to notice that what I did here is I wrote the factors in numerical order. Factors are in numerical order. This is just a convention, right? This is that math etiquette that we've talked about previously. But the question says to use exponents, so we need to combine the repeated factors and express those used as powers. So I have 1, 2, 3 2's, so that's really 2 to the power of 3, and then I have 1, 3, and 1, 5. And so that is the prime factorization of 120 using exponents.